I'm excited. I'm glad it's pretty full.
This is awesome.
Hi, Albie.
So we're doing this right before the introduction, is that right? Mm-hmm. That's what I understood.
Who's doing the introduction? Susan?
Yeah. You're going to introduce it.
Okay.
Right now?
Yay.
All right.
Is it on? Is it on? Hi, guys. My name's Kiki, and this is Kaylin and Seth. And we would love to welcome you to the first of a series of the Psi Beta Evening Lecture Series. For those of you who have no idea, you're just here for extra credit. Psi Beta is one of the awesome honor societies that we have on campus. If you have any questions, you can contact any of us or any of the psychology professors on campus. And to start off, we've got a raffle that we're going to do. So the first number that won the raffle is 330644. Anybody?
Has to be someone in the room.
You have to be here to win, so let's see. Check your ticket. Okay. So the first one was 44. Second one ends with 25625. Yes? Okay, so you can come up and get one of the prizes here. Oh. Nobody wants to claim the 44? I didn't get a ticket. I'll take it. Just kidding. The next number ends in 601. 601. I've never seen people so shy to win stuff. Come on, guys. 601. Next.
There might be names on the back as well.
Oh, ha. Oh, 601 was Candace Surlam. And the other two don't have them. And so the one that I just got handed is 632. Yay! Okay. Good job. So next we'll have Susan up, and she's going to be introducing our guest speaker. Thank you guys again for coming.
Hello, everyone. My name is Susan Barger, and I am one of the VPs for the Psi Beta Honor Society at the Red Mountain campus. I would like to welcome everyone to the first lecture in the Psychology Evening Lecture Series for the fall semester at Mesa Community College. The term ergonomics originates from Greek roots meaning work and natural laws, and it is a scientific discipline that optimizes human well-being and overall system performance. Tonight's lecture topic is Designed for You, Making Stuff Work Better with Ergonomics, and will be presented by Dr. Peter Crane. Dr. Crane is a human factors and ergonomics psychologist who was a senior research psychologist at the Air Force Research Laboratory in Mesa from 1986 to 2012, working with engineers and pilots to develop new capabilities for training pilots and other military personnel. He also served for a year as a visiting scholar on the behavioral science faculty at the U.S. Air Force Academy. For the past 3 years, Dr. Crane has been a senior scientist with Mirror Training Incorporated, a startup company focusing on innovative human-computer control applications. Dr. Crane earned his baccalaureate degree in psychology from Wittenberg University, a master's degree and a doctorate degree in experimental psychology from Miami University in Ohio, and he is a residential faculty member at Mesa Community College. Everyone, please join me in welcoming our guest speaker, Dr. Peter Crane.
Hey, thank you. What I want to talk about this evening is not so much ergonomics as stuff. And stuff is pretty much anything you interact with that didn't come from nature. And it can be simple stuff, you know, doorknobs and room lights, or complex stuff, computers and DVRs and the like. But some of this stuff is just easy to use, transparent, you get your job done very quickly, and some is an utter misery. And so the question that I want to address this evening is, what's the difference between stuff that's nice to use and stuff that's horrible? And is perhaps the problem that we should have read the instructions a little more closely, and then we could have gotten it, right? Well, let me introduce you to a video cassette recorder. Developed in the 1970s, and this was like the first piece of cool technology that was more complicated than a television set, and it would let you record programs off the air and play them back later. All you had to do was program it, okay? And so I actually Googled up, program your VCR, and I got that. Okay, and it tells you everything you need to do, just did this, do that, and that's all. And what happened was a universal reaction was, well, I read the instructions and I did what it said and it didn't work. Really? I read the instructions and did what it said and it didn't work. Really? And everybody said, I must be stupid. Okay, think about this. If no one can make it work, what's stupid? The people or the stuff? And so the question becomes, can you make stuff that works? And here's the original iPod. Notice how thick it is. This came out in 2000. Didn't really catch on till like 2004 or 5 when the iTunes Store came out. But it only had 5 controls. 4 buttons, up, down, left, right, center, and then the click wheel. And then the display. My brother-in-law was an early adopter, and I'm just sitting there going, just mesmerized by this thing. It was just amazing. So the question is, how do we design stuff so that it can be cool, like an iPod, and not a misery, like a VCR? And our goal then is to design for usability. So we want to increase user satisfaction and efficiency, help people get their job done, and not get angry about it. I mean, this seems straightforward enough. Like, what could possibly go wrong? So this, if you'd like to take a trip downtown, is the Phoenix Federal Courthouse. Its central feature is an 8-story glass atrium. Would you believe that this was designed by an architect in New York City? Not anybody who lives in the Arizona desert. It's not air conditioned and it's not heated. It has some fancy voodoo to supposedly make it very comfortable all the time. Security guards in the summer work half-hour shifts. In the wintertime, the baristas wear heavy coats. And in a guaranteed sort of thing, as soon as you know that a building is unusable, it wins an award. And it did. This is inspirational and memorable architectural experiences. Okay, as soon as a building wins an award, you know it's a disaster. So let's go back to this, usability. It's not an accident. User-focused design is a process, and it takes a lot of work from a team of industrial designers, software engineers, psychologists, and specialists in human factors or ergonomics. And you've heard the term ergonomics with reference to expensive office chairs or keyboard drawers. And it's a concept that's been around. I learned it was invented by that guy in 1857, talking about the laws of work. Europeans like the term ergonomics. Americans use human factors engineering. Same. So for a definition from the Human Factors Society, human factors is concerned with the application of what we know about people, their abilities, characteristics, and limitations to the design of equipment. I found another one that was shorter. Ergonomics is the design of human-machine systems to enhance human performance. So if we strip out everything except the important stuff, it's about designing human-machine systems to enhance performance. So that's what we're going to do. We take advantage of what we know about people, what we know about machines, and put it all together to enhance what people do. And it doesn't have to be complex stuff. We can go back to simple stuff like doorknobs. If you look at an ordinary doorknob, realize you've got to reach out, grasp it, twist it, and pull it. And if you've got limited grip strength, and we're talking mostly about older folks with arthritis, that's nearly impossible to do. The lever action, go ahead and put your arm out to the side and try it. You put your arm down, grab a hold, and then you can use your whole forearm to turn and then just back up. And so if you've got limited grip strength, the lever works great, and that's a requirement of the American with Disabilities Act. Room lights. What's room lights? Well, if you look to the screen that's on your left, this is a mail room, and you've got these bright lights overhead pointing down into the work surface so you can illuminate what people are doing. However, in an office where you've got computers with screens, you'll notice that the lights are in fact pointing up. They are illuminating the ceiling in order to give you a nice diffuse light so you can walk around the room, but they don't put any glare on your screen. And by the way, the room lights in here, I can really bore you with these, but these aren't just a simple design of boxes. These are actually carefully designed. I can bore you at your leisure with that. But if you come over to my classroom in AS 195 at the Southern and Dobson campus, you'll see we've got these really nice room lights aiming straight up on a white ceiling. And these are well designed for use in computer rooms. So designing is not necessarily an easy kind of thing. So we're looking at user-focused or user-friendly designs. I love these terms because they suggest that there are other designs that are user-unfriendly or even user-hostile, and we've probably seen some of those. Well, the term ergonomics comes from 1857, but actually it's only in the turn of the 20th century that it got serious. This is Frederick W. Taylor, inventor of what he called scientific management, credited as being the first guy to actually really think about work as a science and worthy of study. And he developed his principles of scientific management. They're not exactly earth-shaking, but this was the very beginning of the assembly line era, and he came up with principles like, let's actually train workers rather than let them train themselves. And let's divide work between managers and workers so managers can plan and workers can work. That's pretty fair thinking. So he was one of the first. The next folks were even more interested. This is interesting, folks. These are Frank and Lillian Gilbreth, who were famous for developing time and motion studies or efficiency experts, and they're also famous for having 12 children, whom they managed efficiently. They did. Actually, their children wrote a book, The Cheaper by the Dozen, which was about how they had a book of French that was sitting next to the toilet, and while you were just sitting there doing nothing, you could study your French. Frank began work as a bricklayer, and you got paid as a bricklayer by how many bricks you laid up in a day. And so his goal was to lay up lots of bricks. And so instead of trying to work fast, he studied the way all the veteran bricklayers worked, and then he came up with the one best system that would optimize the process. So he actually increased the rate of laying bricks from like 1,000 to 2,700 per day. And as an industrial engineer, he actually studied this. And so this is a shot on the left of one of his films, and this is an actual clock that just spins around. And the way the bricklaying was done then was the bricks were pretty much piled up on the floor, on the scaffold on the floor. The bricklayer would bend down, pick one up, look it over, find the best side, then butter it, switch hands, butter it, put it in place, tap it, reach down, pick up another brick. The way Frank redesigned it was a two-layer scaffold, and you can see that the bricks are now up at about thigh high, They've been placed in the correct order so that the good side is down. So he reaches over, picks up a brick. The good side is now in his hand. Excuse me, the good side would be, the good side's in his hand. He butters the back side, puts it back down, and the mortar in the hod is right there, also at thigh level. So keep moving things around until it's just right. He's famous for saying there was one best way to accomplish a task, and did a lot of contracting with early 20th century manufacturers. And he was the one who developed the procedure where a surgeon would keep his eyes down on the surgery and ask, tell the nurse to hand him something rather than pick his head up, look around in a tray, find what he was looking for, and look back down again. If you'd like to see this in action yet today, go to any fast food operation. I know some of you have worked fast food, and there was one and only one way to do something, right? And that was the way that the experts came up with. And that's how you made money. Package delivery guys, if you get a chance to see a UPS truck, when the doors open, look inside. The ceiling of the truck, the roof has been taken out and replaced with translucent plastic so the daylight shines through and he doesn't have to find a light switch. Saves a step. Runs in, and by the way, the UPS guy won't ring your doorbell. He knocks because he doesn't want to spend time looking for your doorbell. It's all time in motion. Lillian was even more interesting. She had a PhD in psychology from Brown University, and she actually co-authored Frank's books but didn't get credit for them. And Frank died in 1924, and industry wouldn't hire a woman engineer. So, as she wrote later, she couldn't get in the front door, so she broke in through the kitchen. This was the transition era from Victorian-era stoves, wood stoves and ice boxes, to gas and electric appliances. And there was fierce competition for getting customers for this. And so first Brooklyn Gas and later General Electric hired Lillian to design kitchens for them. And turns out she's a brilliant psychologist, not much of a cook. And so she could bake a cake. And so what she did was she baked the same cake in kitchens of a variety of designs, counting the number of operations and the number of steps. And from beginning to end, she reduced the number of operations by 34% and the number of steps by 84%. And so this is the 1929 The Kitchen Practical. And does that have a laser in it? No. Here's the design. And so here's the refrigerator. Next to it is counter space, and above and below is cupboards, so you can store all the equipment you need there. Take stuff out of the fridge, prep it on the counter, put it in this rolling cart, roll the cart over to the stove. Here's the oven and stovetop. Cook, roll it over to the sink, put everything back on the cart, roll it back, put it away. Your kitchen looks a lot like that, and it came out of Lillian Gilbreth's designs starting in the 1920s. Okay, that was early industry. Next big push for human factors came out of aviation. In 1935, Boeing introduced the experimental version of what became the B-17, flew it from Seattle to Wright-Patterson Air Force Base to demonstrate it for the Air Force, and on its first demonstration flight, it crashed, burned, and killed the crew. Not a successful debut. And it was determined that the pilot, who was Boeing's chief test pilot, the smartest, best guy who could fly in that day, had failed to unlock the elevator controls, so when he went to pull back on the yoke, he couldn't get the airplane to come off the ground, and he ran out of runway. If he was the smartest guy there was. So if he couldn't fly it, was it flyable? And what happened was the test pilot community responded by inventing the checklist. And after some initial resistance, everybody discovered that the checklist not only reduced accidents, but it made them more efficient and actually reduced workload. It made life easier for them. So they, in fact, invented checklists for takeoff and for landing and for navigation and bomb runs, and That's just part of the pilot lore now, is you do your checklists. And the B-17 went into production. Here was another one of pilot error. The B-24 was a 4-engine bomber, and when the pilots trained successfully in the United States, they went to England, and they promptly crashed. And they crashed because they would raise the landing gear just before touchdown. Not a wise thing to do. So this is obviously a pilot error, but the question is, why would a pilot do that? And the problem was poor cockpit design. Turns out the landing gear and the flaps handles were right next to each other, and here they are. You can see them in between the consoles. And the positions where one was gear and one was flaps was left-right in the training aircraft in the States, but they were right-left in the operational aircraft. So the only way you could get it right was to look. And if you kind of see where that is, it's off the pilot's right ear. So he's going to have to literally kind of lean over and look behind him while he's trying to land this airplane when the runway is right there. And apparently these took a whole lot of oomph, a lot of heavy control, and so they would just do it by touch, and they'd get it wrong. So what happened was that the gear and flaps handles were then redesigned. The flaps handle looks like a flap. The gear handle looks like a wheel, and they still do. And so the point is you can tell them apart by touch. Get it? You're enhancing people's performance. Here's where I got into it, which was office computerization. Up until early 1970s, the only people who ever used computers were computer professionals. And the IBM PC wasn't introduced till 1981. But before that, in the mid-70s, two groups of workers that were not computer professionals started using computers. They were using terminals. And they were secretaries and reporters, and they used them for word processing. They replaced their typewriters, and guess what? Everybody hated it. They did not like it at all. And so the reporters complained that, well, that screen's causing cataracts. And the secretaries complained they were causing miscarriages. And so this was investigated by the National Institute of Occupational Safety and Health, which is part of the Center for Disease Control. And actually, no, there are no health effects with respect to cataracts. Your reporters are middle-aged men, and some of them get cataracts. And no miscarriages. Most of the secretaries were younger women, and they have pregnancies, and some of them end in miscarriages. But they did discover some problems with eye strain and neck and shoulder issues. So NIOSH looked around who might know something about this. And my professor is a visual scientist, so he got contacted, and so I came along for free. I'm a graduate assistant. You know, you hire a professor, you get the graduate assistant for free. And we looked into eye strain, but actually we thought neck and shoulders was more interesting, so we looked at the design, the ergonomics. And if you look at the reporter's keyboard, look where it is. It's below the level of his desk. It's below desk height, whereas the initial computer terminals were placed usually, look how close that is, because the back is so big, and it's got this very thick keyboard placed on top of a desk. Now, okay, now you got to try this. Put your hands up like you're going to type, but you put them at chest level. Okay, and now just sort of raise them, and look what happens. Your wrist is way bent off to the radius ulnus, so it's bent to the outside. So this is called ulnar deviation, great term. But if you're doing like that, you're going to get carpal tunnel. And so the design of the workstation had to be changed. By the way, I found this picture when I was searching for photographs to put in here. This is a student at Union College in 1972, which was the very first college to introduce computers into dorm spaces. And if you look, they've got her kind of crammed in here because that monitor is so huge. And she's sitting side saddle, and you can't quite see it, but she's got her foot propped up into an open desk drawer with one arm propped on her knee and the other one propped over there. And it's a good thing she's young, because that would kill me. The Germans got on this before everybody else, and they designed the keyboard, the workstation that you are probably very used to. And what they insisted on, first of all, was to get rid of that thick keyboard and go to a thin keyboard. And I was going to hold up the keyboard here and show you how thin it is, but it's on a short wire. So homework, go home, flip the little feet up. The keyboard is 31 millimeters thick at the home row. Germans, they like precise standards. And they also insisted on the keyboard drawer and the adjustable chair. And you look at that forearm. The point is for you to get your forearms all the way down so that they're parallel to the floor. So go home, raise your chair, lower the keyboard, get your forearms parallel to the floor, because if you try it now, your arms are relatively straight. If you're up like this, they're bent. Get your keyboard down, hands parallel to the floor, your forearms parallel to the floor. Also put a little down angle on it, and if you're an older worker, you need special bifocals. I can bore you with that. No, it's, if your folks are kind of, what'll happen if you're wearing ordinary bifocals and you're using a computer screen, you end up rocking your head in and tipping your head up, and you're doing these. Bad idea. Get better glasses. I can tell you what the design ought to be. So where we are now is the next big push, which is software usability. Websites, software apps, how do we design these so that people can actually use them? I don't know, bless engineers for all they do, but they sometimes don't think about us non-engineers having to use the systems. And what makes software usable? This is actually an ISO standard that says software should be learnable, efficient, memorable, free from errors, and produce some level of satisfaction. So I started looking around at different software systems. Learnable. Okay, when Dr. Lipinski asked me to do this presentation, that was in June, when not even a glimmer on the horizon that I'd be working on the faculty, which came in mid-August, late August, like a week before classes started. And so I had to jump in and learn how to get on the system. So I go onto the new employee's website, and they send me to this utterly obscure place, and I'm going like, I have no idea. But then it said, and here's the instructions. Oh yeah. I printed out the instructions, walked me right through it, got me in and out, and I'm all set up. So I don't think it was a learnable system, but they had a great workaround because they had a beautiful set of instructions. Do it, and read the instructions, do it once, you're done. So it was a nice solution. Efficient. Can you use the task? Can you get the task done quickly? The first version of Outlook, email, had this wonderful feature of an attachment. You could attach a file, like a picture to it, except you could only attach one file at a time. So that meant you go attach, file, select, browse, select, open, attach. Now you have your second picture, right? Guess what happens? You start all over again. They very quickly, so you could attach several files, but it was pretty grim at first. So that's an inefficient bit of software. Memorable. You've used the software, you've gone away for a week, you come back. Can you remember how to use it? The keyboard shortcuts in Windows. I can remember Control-C for copy and Control-V for paste. None of the rest. I looked these up on Google to make this slide, and I'm going like, really? I did not know that. So yeah, the keyboard shortcuts are handy, but not particularly memorable. Okay, errors. How many errors do users make? How severe are the errors? And can you recover? And the cool one for this is door handles. All right. Here are two doors with a handle on the inside, handle on the outside. So I've got 4 door handles, and they're all exactly the same. What could be the problem? Well, the problem is that one of these doors is not like the other. One of these doors is just not the same. You got a push door and a pull door with the same handle on it. And so you've got people going up, yanking away. And you got to put a sign on it to tell people how to use it. Kind of a rule, if you have to put a sign on something to tell you how to use it, it's not a good design. And then somebody found this and posted this picture. That one's a favorite. And finally, user satisfaction. Do you like doing your work? Is this a pleasant design to use, or are you constantly fighting it? Well, those are the criteria, usability. So how do you design so that you actually get it? One of the first guys to think about this was Paul Fitts, one of the originators of human factors. And he said, okay, let's make a list. Here's what people do better than machines. Here's what machines do better than people. And we will allocate to machines the things that they do, and to people what they do. Good enough idea. The list has changed, but it's kind of good news, bad news. Here's one that is pretty good news. This is CAPTCHA. You've all seen this. These distorted letters can be read by humans, but not by computers. So companies put these on their website to make sure that there's a person on the other end and not some software trying to ping them. That's the good news. The bad news was this is called a multi-position letter sorting machine that was used in the 60s and 70s in the post office, following Fitts' principle. Machines are better than humans at handling materials like letters. Humans are better at machines than reading addresses. So all of these people here are going to read the first 3 digits of a zip code and type it in. And this is a silent video, so I get to keep talking. But that's your job. You're sitting there at this console, and you're going to get fed mail, and you type in the zip code. About that fast, 3 digits. Here you go. It's a two-hand, and this is machine paced. It's not responding to you. You're responding to it. So this machine is just feeding you letters, and you stare at that letter, and you type in the first 3 digits of the zip code. And watch this poor guy. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. That's your job. Keep it up all day long. They're not in use anymore. There are now machine codes that read much faster than people do, and you don't have to have people do this. But this is like, one of the worst jobs I think anybody's ever invented. And what's interesting, I got told, is you'll notice that every single soul on this line is wearing headphones because, first of all, you want your music to keep from going insane, and secondly, they're very loud. So your brain is being fried, and you're going deaf. Okay, well, Fitts' principle was a good start, but how do we design for usability? And the godfather of usability is Donald Norman, who in 1988 wrote a book called The Psychology of Everyday Things. He was a professor at UC Santa Barbara, and he got interested in why some stuff just was hard to use. And he wrote his book, and it got read by psychologists who loved it, but no designer ever read it because it was called psychology. So why would the designers use it? So he promptly reissued the book as The Design of Everyday Things. It's the same book. But now it's in the design sections, and design people have found it, and they love it. It's great. And so Donald Norman left academics to go work for Apple and then later for Hewlett-Packard. Now he has his own company. And he says, good design delights the user and depresses the competition. And so he just looked at stuff in order to look at designs. And he came up with his principles. And Norman's principles are easily found. And the first one he calls affordance. It's a word from perception that means gives a clue. Does the object itself tell you how to use it? Like you pull a handle and you push a flat plate. You push a button, you turn a knob, you flip a switch. So the affordance provided by the thing helps you use it. I tried to think of some examples. Signage in international airports. Signage is a real word. And if you've been around airports at all, once you get to these big international airports, it's actually very easy to find your way around and find what you want. The signage systems are very well put together. Here's an emergency stop button. That tells you what. I've never seen that electric plug, but I want one. Very easy to grip, push in, pull out. We're going to take a side step here. We're going to look at affordance in the men's room. Human factor psychologist goes into that men's room on your left, and there was just the throne there, no urinal, and that bit of porcelain in the corner. And he goes, wonder what that is. And there's a little sign. Now, I wonder why he felt compelled to put a sign that says this is a mop sink on there, but we won't dwell on that. But if you have to put a sign on something, it's probably not. Over on the right hand is a more successful design. This is a European urinal, and you find them all over, like this one I think it was in the Netherlands. And right down in the center of it is a fly. There's not a guy who's ever lived, man nor boy, who cannot try and knock that fly down. It turns out it's etched in the porcelain, and it gets you to stop making a phone call and pay attention, and supposedly it helps in cleaning costs. Don't know if that's true, but it probably is. Visibility. Can you see what you're doing? Canvas, the learning management system that we all know and love. When I was learning how to use it, I would put my content in, and I'd set it all up, and I'd go, okay, I'm good to go, right? And I would then exit out of the screen, and everything was vanished. Well, it turns out there's a save button, but the save button is off the bottom of the screen. If you don't know it's there, it's invisible. You gotta slide the screen up before you can see save. So if you, oh yeah, and there's no message that says, hey, do you want to save this before you exit? Lets you right out. Automatic faucets in restrooms in the airport. You got your hands down there. You feel like a rat in a Skinner box, right? You're sitting there trying to get this thing to turn on. That's because the sensor's underneath. You can't see it. And so that's a problem of visibility. Feedback. Do you get information back from your gizmo? Our phones. These are great. Oops. So every time I press a button on my phone, it's giving me a little message. And if I bring up the camera and I take your picture, I get that great sound. That's feedback. That's all designed in there so to help you know that the camera just did something that your phone is. This is brilliantly designed. Oh, I like that. Constraints. Constraints is, do we keep people from making mistakes? Do we kind of back off so that they don't do things wrong, like putting in a USB upside down? And it decreases choices. It's kind of like the opposite of affordance, except if you'll notice, this port right here, that one smashed to smithereens because someone tried to jam something in there upside down. So the constraints apparently don't always work. Grayed out options in Windows software is the same sort of idea. Mapping, what's the relationship between controls and their effects? So here is the seat adjuster for a car, and the controls are just perfectly laid out, showing you where everything is. This is my heartburn, personal problem. But if I go to adjust the stereo, I bring up the knob that says balance, and I turn the knob left and right, and the sound moves left and right. I turn it to fader, turn the knob left and right, and the sound moves back and forth. I don't know how you're going to solve that one. If you can figure it out, I hope you do. Here's a nice problem here. Mapping. You've got two burners, two burners, two burners, two controls, two controls, two controls. That's easy. Which one's front and which one's back? Yeah, I don't know. Also, this design with the knobs in the front is somewhat dangerous because if you got little kids in the house, they just love to play rocket ship with those. So what you do is you put them all in the back, which gets them out of the kids' way, the mapping problem is the same, and now you've got to reach over the top of the hot stove to get the control. Yeah. This one is a brilliant design. We've got 5 burners, 5 knobs. They're all in the same pattern. You know exactly what's what. That's a fine example. And then finally, and consistency. The things, similar operations use similar tasks, so that here's our VCR controls. That's the one thing from that technology that's lasted to this day. And there are occasions when you want to use standards. These are Australian road signs. Everywhere in Australia, they'll have the same signs. Here's good news. Red light, green light. We know that. It's always the same. Now, here's a problem for consistency. North America, of course, you drive on the right, so if you step up to the curb, you look left. And if you're in England, where they drive on the left, you would think you'd look right, except in London. And everybody takes pictures of these. In fact, I downloaded these off of some website. Because there's so many one-way streets in London, nobody knows where you're going to get run down. And so you've got to write on everything occurred. Look left, look right, look left, look right. If you got to put a sign on something, okay. So here are some of Norman's principles. Affordance, visibility, feedback, constraints, mapping, and consistency. So we know here's what makes a usable design. Here are the things you can put in to make something usable. How's the design process work? Well, here are 2 classic engineering terms, BOGSAT and TLAR, well known to the engineering community. BOGSAT is a bunch of guys sitting around the table, and TLAR is that looks about right. And the way user experiences are traditionally done is you get a bunch of guys sitting around the table, and you kind of sketch a few things until somebody says, that looks about right, and you're done. Don't do that. There is a very formal process for designing for usability for things like websites. And you actually start by thinking about who's the guy on the other end? Who's going to use this? And these are called users. That's me and you, the guy who's actually trying to get something done. But there's also stakeholders of other people who interact. So as Susan said, I used to work for the Air Force Research Laboratory. When I had to take a business trip, I'd call up the travel office. We'd work it out and be done in a couple of minutes. We obviously had to get rid of those contractors, so we went to something called the Defense Travel System. What an agony. User hostile. But the original users are me, the traveler. I got to go from Phoenix to Washington and back on these days. And the travel industry, the airline industry that wants to sell me a seat. But the stakeholders also include my boss, who has to approve the trip and authorize the funding, accounting, who's going to actually pay for the trip, pay for the airline ticket, administration, and they're going to cut the orders and issue the travel orders. That's you, right? Yeah. And then auditing, that's got to keep track of all of us. So there are a lot of stakeholders. Do you want the job of identifying who the stakeholders were in organizing usahealthcare.gov, which was the, if you remember from a year ago, the fiasco of the opening of the Affordable Care Act, because that was 50 programs and you had to identify all the stakeholders in all of them and take care of their needs. Very difficult task. Now, once you've identified who the stakeholders are, you want to establish, you don't just say, you know, here's somebody trying to kill zombies, or here's somebody trying to return a library book. Talk to them. Find real people who are doing this work and find out what are their tasks, what are their goals, what are their motives, how much education do they have, how about training, how about support, how about supervision, okay? And if real users aren't available, a psychologist, or it's actually a software engineer named Alan Cooper, in his wonderful book, The Inmates Are Running the Asylum, said, invent them. Create what he called persona. Give them real names and give them backgrounds and interests and education. And when I was looking up persona to find this slide, this is from a company that does consulting on this level. And here's Steve. And they made up a card for Steve. And so now you're going to ask, how is Steve going to use this tool to meet his needs? And you do it by establishing storyboards. You develop your user experience by putting together storyboards with whiteboards and stickies, and then use scenarios. A scenario is, I have a library book, I want to renew it. What do I do? What do I do first? What do I do second? What do I do third? I want to go from Phoenix to Washington and come home again. What do I do first? What do I do second? And then you ask, how would Steve do each step in this user experience? And this is called a cognitive walkthrough, and it's done by the design team. And you can do it on paper, on whiteboards, use yellow stickies, there's software, no coding. You're doing this all in pencil and paper. And when you go back and forth until your walkthrough is happy, Steve can do his job. When you're ready to write your prototypes, you start building code and have a formal evaluation that's called a heuristic evaluation. And there are companies that do this for a living. I bumped into a bunch of them as I was trying to prepare this. You'll end up hiring a team of 3 to 5 experts who will run through the scenarios with lists of heuristics. Norman's principles would be one example. I found these heuristics online. And they've got the checklist of heuristics in one hand, your scenario in the other, and they act like Steve trying to do the job and say, does Steve have the support he needs? Does Steve have this? Is Steve confused? Can he get help? And so you can go through the heuristics, and at the end of this, they will hand you a very fat report telling you what's good with your software, what's not so good, and help you get to your next step, which is called a usability evaluation. This is really formal, where you conduct lab or field tests with real users, and you want to get real folks, not your brother-in-law, and give them real-world tasks. Give them your scenarios and have them use the system. And what you do is you record. How long does it take? Is it efficient? Does he make errors? Does he have to go backwards to do something over again? Does he get help? And it's useful. This one's kind of interesting, and it's fun to do. Concurrent think aloud. While you're recording their interaction with the computer or your software app, you have them talk out loud, just like all of us do, except we tend not to vocalize it. But you get to, oh, that didn't make any sense at all. What? Where do I do this? And you get them to say it. And so you're trying to capture what it is that they're thinking as they're doing it. And here's how it ought to go. Okay? Your user does it, your researcher takes notes, you record everything. Doesn't always go according to plan. Okay. So why go to all this effort? Okay? And return on investment is amazing, because fixing things early on paper or on prototypes is very inexpensive. You can do it pretty quick and save some money, as opposed to trying to issue a new software release. If you fix problems only in beta testing, that costs even more, and if you fix it after release, So look at Windows 8. Windows 8 was intended to allow people with tablets and anything with a touch screen to use Windows, except that all the installed base of us who have keyboards and mice found it impossible to use, and they had to go back and issue a re-release they called 8.1, and it still doesn't work terribly well. So they tried to get new users and forgot their installed base. Not a successful idea. So, what's new? Well, as Susan said, my day job, or at least my day job was, I'm a senior scientist for a tiny, tiny startup company called Mirror Training. And we're doing a project called FRAM, Functional Utilities Requirements Utilities Module. And we're currently being sponsored on contract from Naval Air Warfare Center. And the Army's Force Projection Office is our transition customer. And what we want to do is to provide people doing usability testing for soldiers using battlefield equipment with a single shop for collecting all their data. So we take a computer, a simulator, and a scenario generator, and we've currently set up for a battlefield robot. And we have a video camera, data recorder, an eye tracker. Eye trackers are really cool because they show you where your subject is looking, where the operator is looking. It's like having a key into the guy's brain. We record also heart rate variability, which indicates stress and anxiety, and also we've got some EEG data, and we collect it for later analysis. So right now we've got 2 graduate students at Old Dominion working on this. This is Eric, who's working with the evaluator station, and Alex, who is trying to drive a robot on that screen. And let me show you a video. This time it's Eric who's driving the robot. Yes, that's what I said. Okay, now. Okay, so here's Eric driving it. This camera is looking back at him. This is collecting the EEG data, and if you see blue spikes running up and down here, that means frustration. This is his heart rate and heart rate variability. Turns out that if your heart rate it's just having a good time, low anxiety, you get a lot of the high standard deviation of the interbeat interval. If your heart rate goes into clockwork, that's stress. And then this is the user screen, and this red dot is his eye position. And watch this menu key, because what happens is that as he's trying to set this up, he has to keep zapping back to the menu. So it's obvious to us that it's in the wrong place. So he's doing setup now, and it's now configuring. That's how fast your eye actually moves around. And he's good at this now, so he's gone back and forth. Back down to the menu. Yep, sets it up. And when he gets up to here, when he gets to this idle button, he's going to try and drive the robot. And look down here. Yeah, I've seen some spikes. Yep, okay, now he's going to put it in drive. And away he goes. Now, what's interesting is now that he's driving it, watch the red dot. As it grows, he's actually staring at something. So that red balls that we're going to see a couple here that really loom large, is he's actually being able to look at something and stare at it for a second. But you see his eyes are constantly sampling. And he's searching for improvised, there he goes. He's searching for improvised explosive devices. He's searching for something that might look like a roadside bomb. And you can't do it all at once, but every now and then, particularly when he was doing his setup, if you look down here to the blue screen, when he was trying to get those buttons right, you'd see this huge blue spike as he got madder and madder at that thing. Okay, so this is our product. That we're working on at the moment. And so here's the kind of data we get. This recording across the bottom is an entire pen recording of what happened. We can look from beginning to end at everything that happened in this scenario. And analyzing the data, we came up with a set of positive characteristics. Here are things that looked good. Here are things that weren't so good. And we're helping the designers redesign the control system. Now, here's something completely new. This is called a leap motion gesture recognition device. It's just the size of your thumb. You plug it into a USB port in your computer, and it knows where your hands are. It's kind of like a Kinect. Kinect knows where your arms are. This thing knows where your fingers are. And a company in San Francisco, Leap Motion, invented it, but didn't quite know how to work it. So they ran a project called, you ready for this, Accelerator. Okay, that's what they do in software. There were 10 finalists. My company was one of them, and they went to San Francisco. There was an office that was near theirs, and all these 10 teams worked on their applications. And so this is a different team. This isn't my team. This is a company called Motion Savvy. These are all engineers, and they're all deaf. and they wanted to use the leap motion gesture recognition system to recognize American Sign Language. And they would attach it to a tablet. They would then do the recognition over the tablet. The software would turn their hand signals into spoken text. The tablet would speak to the person you're trying to talk to. The person then would say something back. They would then have like Dragon Talk in there that would turn that into text, and he could read it. And we have a video here. Unfortunately, the sound is not working well. It's the only one that I'd like to have some sound working on, but we just can't hear a lot.
Hi, everyone. My name is Ryan P. Campbell. I'm the CEO of Motion.
So this is Ryan. He's the CEO, and he's explaining that for dealing with speaking here, the only real solution in real time is an interpreter. For this event, the interpreter worked very well, but in real life, you can't have every deaf person walk around with an interpreter. So if I can find the right spot. So even if we had good volume, this doesn't come through very well. But he's about to give a demonstration.
I'll show you the demo. It didn't work now. Okay, great.
So what he does is he signs over the tablet with the leap motion connected, and then it's speaking to that guy. He asks a question. The other guy answers. It turns that into text. Ryan hears it. He signs back. And it recognizes his speech and translates it back into spoken speech for the other, for the listener. Really cool. It's, I think, still in the early development stage. So here's my company. Working with Battlefield robots, we were driving them. Remember Eric driving the robot? He had an Xbox controller in his hands. And he was forever pushing switches and trying to get it to work. And so we looked at the Leap controller. It's that little square right there. Can we connect it to a Battlefield robot where a soldier can drive this robot out to a suspected improvised explosive device? That's these dynamite, right? Yeah, it's tubes of red paper. And what he's going to do is he's going to place what's called a disruptor charge, which is a little bit of C4 explosive, next to it. And what we've discovered was that it's very efficient, takes little training. And one of the reasons it works so well is, see these green dots right here? This is actually the operator's hand. So he moves his hand, and the gripper closes on whatever he's got gripping. He moves his hands left and right. The robot arm moves left and right. And it even changes color. These green dots change color to yellow when he's near the edge of the envelope and red when he's hit it. So we got one movie left. Here we go. And so what's happening, here's the leap. And so here's my colleague. There we go. Now look for a second. He's looking through this camera attached to the robot, and the gripper arm is down here, and there's a second camera up here. So he's dealing with explosives. He's not next to this robot. He's a mile away, looking at a computer screen, watching what the robot arm is doing. So as he moves left and right, up, down.
You can even make it undulate like a snake.
And he's just waving his arms over that, making it do exactly what he wants it to do. Now we're going to take the charge, that that package down there. He grips it, picks it up, puts the disruptor charge on the IED. Let's go. Brings it back. This is his view that he sees from the computer. You'll see that he's got his robot hand. He's got a second view of the gripper. Reaches down. Look on the small screen on the right. Now he just pinches his fingers together, picks it up, rotates his arm. And away he goes. So if you're looking for investment opportunities, so anyway, where have we been? Well, we talked about the concept of ergonomics, of trying to enhance the users, people's lives by making the machines and the stuff they use better. History, we saw industry, the Gilbreths laying bricks and baking cakes, people trying to not crash airplanes, office computerization, and then finally took an extended look at apps and websites. We have the usability criteria. This is what makes stuff usable. We saw Norman's principles on how to achieve that, how to achieve usability with things like affordance and constraints and mapping. And then looked at the user-centered design process so an actual team can implement this and build a user-centered application. And then finally we took a look at some emerging capabilities which are, and we actually conducted a user test with the robot. We didn't just make this up. We used the FRAM user evaluation system to conduct a user test at Fort Benning with actual battlefield robot operators, and they're ready to buy it. I mean, they're going like, hey, look at that, So we actually have used our usability test software to conduct a usability test of our robot system, if you followed that, okay? And so that's our whole goal then, is to enhance usability in the user-centered process with teamwork of engineers and coders and the human factors guys in order to make something so that it's fun to use, not frustrating, and you can get your job done with a minimum of hassle. And that's my get off the stage slide. So thank you.
That was awesome, right? I think it's kind of unanimous. I want to get one of the sign language things. That's so cool. So when you walked in, there was this nifty little evaluation sheet sitting on your chair. We're going to go ahead and ask that you go ahead and fill it out for us. And in the meantime, Dr. Crane, do you mind entertaining a few questions? All right, so if anybody has questions, feel free to go ahead and ask. And we'll give about 5 or 10 minutes to get the evaluation done. And then we will go ahead and I'll pop back up at that time.
Okay. Oh, actually, yeah. Put your head down, fill out the form first. But once you've done that, yeah. Yeah, I think most of us have been there, done that. Certainly with your phone. You know, how many of us have a smartphone for like a year and a half and you go, oh, this is that. Why didn't you know that? Oh, yeah. The lights. Okay, the question was about the lights in here. These lights actually aren't just straight pieces of plastic in between the light in the baffles there. They're actually shaped like parabolas like this so that the light reflects off them and aims straight down so that when you look up here, you don't get glare coming in your eye. The light is aimed very carefully straight down. Yeah?
So from a programming standpoint, what technology were you using to develop that? I mean, it's kind of an overview of it.
Yeah, okay, here's where I get embarrassed about working for a tiny company. We are a distributed company. The headquarters and the engineers are in Florida. The professor and his graduate student are in Virginia. The software guy's in Minnesota, and I've never met him, and I don't know. It just shows up, and I load it into my computer and read the instructions. Yeah, yeah.
You know, I started to really think about Apple and iPhones and iPads and all that stuff, and I was thinking about how much work and how many man hours went into making sure all the programs worked right. And that's why we're on like 6 now or come out with a new one every other year or whatever it is. So how many people do you think is on like a team like that?
Well, Steve, if the godfather of usability studies is, of course, Donald Norman, but the guy who actually was the designer, or the guy who put together the design teams, was Steve Jobs. The mouse itself was actually invented at Xerox Palo Alto Research Center, which is a human factors lab. The problem was they spent so much money devising the interface that they went broke. So Steve Jobs actually hired all of the engineers from Xerox to build the first Lisa, and then which failed, but then later the Macintosh system. So yeah, and then that's where Donald Norman first went to work, was at Apple. After he left academics. Yeah, they work a lot on that. Okay, yeah. What I see as the future in human factors is going to be in software, and I don't see software going away or reducing. So what's going to happen is that they're either going to have in-house human factors guys, or more likely consulting companies, and there are zillions of these consulting companies out there that will help you with any number of ways to go on this. I would say the sweet spot here would be a master's in human factors, or go over down the street to the Arizona State's Polytechnic campus and talk to the applied psychology department about a major there. So within applied psychology at Polytech, not at Tempe, they do have a program that deals with, and there's some wonderful human factors guys there on the faculty. Yeah. It kind of depends on who wants to be in charge. Engineers rarely seem to want to be in charge, and I always found myself being the team leader because I was the only one that felt like doing it. But yeah, a lot of human factors can be engineering, and so there are some programs that are very engineering oriented. In fact, Donald Norman's bachelor's degree was in electrical engineering from MIT. So what I found to be useful is to have a team, which is you have engineers that are waiting to be told, you tell me what to do and I'll do it. And subject matter experts who go, why would you do that? And the researcher in the center is putting it all together. Yeah.
What are the applications, do you think, in education? I beg your pardon? What are the applications in education?
Oh, good one. Applications in education. Online education, can you make something that's usable for both instructors and students? That's going to be the biggie right now.
Well, I was thinking more primary education.
Yeah.
That seems to be our biggest issue these days, is that dropout rate is increasing. We seem to be losing the right way to teach kids.
Yeah. I don't know. Education applications are the technology of the future and always will be. It feels that way.
Smartphones have gotten more and more popular.
Yeah. Well, I think in some ways we're actually going to go back to the first comment of the gentleman of, if I knew what it was doing, it could probably be very helpful to me. So the problem is going to be not only coming up with a clever app, but making it transparent so the teacher is willing to use it. And that's got to be a growing market.
So the school I work for is a first grade teacher, kindergarten teacher uses a smartphone to teach your kids.
Yep. Okay. Okay.
Okay, everyone, welcome, or come and help me out in giving another big round of applause for Dr. Crane. So what we'll do is we'll have you go ahead and turn your sheets in at the back of the room there. And thank you so much for coming. Have a good evening.